Okay, welcome to the last day of the F equals ma practice problems. So we are going to look at the torque and lever, which is also a very common topic on the F equals ma. So just a review on the idea of the lever. So we have learned that the lever has a fulcrum, and then we also have the resistance arm and also the resistance force, which is going to be over here. And then we also have the effort force and the effort arm. The reason we have to define this like values is because when the lever is balanced, we always have the resistance force multiplied by the length of the resistance arm is equal to the effort force multiplied by the length of the effort arm. And maybe we have only seen these cases before, but also there will be some cases when the force is not perpendicular to the lever. Just make sure that the lever arm or also like the resistance arm or the effort arm has to be perpendicular to the direction of the force. So we have to draw this perpendicular distance to calculate the actual effort arm or the resistance arm. Okay, let's take a look at some practice problems. So for the first one, we have a 1 meter long stick with uniform density is allowed to rotate about a 0.30 centimeters from its ends. So we have the stick to be over here, and then we can also define the fulcrum to be, say, over here, and this will be 30 meters from, say, this end. 30 meters. And then the stick is perfectly balanced when a 50-gram mass is placed on the stick 20 centimeters from the same end. So we have the weight to be over here. Let's use the purple color to be here. And this will be 20 centimeters. And the weight here is going to be 50 newtons. Okay, and then how is the stick going to be balanced? That's because there will also be the weight of the stick itself, which is exerted. You can kind of see this as exerted on the middle of the stick because of the uniform density. So we have this to be the actual weight of the stick. Let's call this to be the Fs. So now it will be clear that we have a lever system. So if we just use the formula here, all we need to know is to use the resistance arm, which will be 20, actually will be the distance from the object to the fulcrum. So it's going to be 10 centimeters. All right, so we have 50 newtons multiplied by the 10 centimeters is equal to the Fs. And what about the effort arm? This will be equal to 20 centimeters because this will be right at the middle. So this will be 20 centimeters, and we have multiplied by 20 centimeters. So doing the calculation, we have the force is equal to 25 newtons, which will be half of the weight. Okay, and then we can have the answer choice C. All right, so for the second one here, in this case, we actually need to find the minimum force needed to roll this cylinder over this step. So in this case, we have to use the property that the lever arm is going to be perpendicular to this force. So if we want to find out the minimum forces, we have to find the fulcrum first, which will be this point here, right? So you can think about the cylinder as doing the lever system around this point. So we will need to find the distance to be over here. So this will be kind of our lever, and we have to apply the force perpendicular to this case, to this arm. And the reason is because if you have something to be like this, and you can see that the arm will be definitely smaller than this diameter, right? Because of the right triangle. So if you want to find the minimum forces, you have to find the force perpendicular to this lever. Okay, so once we have this here, the force is the things we want to find, and we can also find the effort arm to be just 2 multiplied by the radius. So this will be very easy. We have force multiplied by twice of the radius. But now we also need to find out the resistance. So the resistance is going to be, first of all, the weight of the cylinder itself, which is equal to G. But then what about the resistance arm? Keep in mind that it has to be perpendicular to the resistance of force. So we have to connect this point, and then we just want to find this distance here. So we have this to be R, and this will be actually equal to H. So we have this part here is equal to R minus H. So now we can also calculate the resistance arm will be the square root of R squared minus R minus H squared. Okay, so now it will just be some algebra. We can simplify this to be F is equal to, we will have the square root of, if we just cancel this out, it will be twice of the R times H minus the H squared, and divided by the 2R, multiplied by the G, and that will be the answer choice C. So for the second one, just know how to find the minimum forces and then do some calculations, and you just need to know the two forces and then also the two arms. Okay, yeah, so that will be all for the F equals MA daily practice.